impulse response of a unity feedback system is given by the C of t. Then we have to find out the open loop transfer function. So if the input is unit impulse, then the output is nothing but a transfer function itself. So the system is unity feedback system here. So the transfer function h of s is minus 1 by s plus 1 square plus 2 by s plus 1. So if we simplify this one, s plus 1 square minus 1, 2s plus 2, which is nothing but 2s plus 1 by s plus 1 whole square. This is the closed loop transfer function for a unity feedback system. We have to find out the open loop transfer function, that is g of s. We will get 2s plus 1 s square plus 2s plus 1, subtract numerator from the denominator. We will get 2s plus 1 divided by s square. That is, option B is correct. PCM system, the number of bits are increased from 5 to 7. The SQNR increases by a factor of. Suppose whenever n equals to 5 bits, SQNR is nothing but 3 by 2 2 power 2n, which is 3 by 2 2 power 10. Similarly, whenever n is equals to 7 bits, SQNR is equals to 3 by 2 2 power 14. So how many times it is increases we have to find out. So this is SQNR 2 divided by SQNR 1, which is equals to 2 power 14 minus 10, that is 2 power 4. The signal to noise ratio is increased by 16 times, that is option B is correct. A source emits 128 different symbols. The maximum entropy is. The maximum entropy occurs whenever all the different symbols emitted by a source having equal probability. That is, the maximum entropy is equals to n, h max is equals to n into p log base 2 of 1 by p, which is 128. This is bits per symbol log base 2, this is 2 power 7. So which is equals to 7 bits per symbol. That is, option D is correct. Capacity of an ideal AWGN channel with infinite bandwidth is. For a channel whose capacity is defined as bandwidth log base 2 of 1 plus s by a. So if bandwidth tends to infinite, if we simplify this one, that is limits b tend to infinite c, then we will get this as 1.44 s by n. That is, option B is correct. The delta modulator is m of t is equals to 0.1 into t. Delta modulator operates at a sampling frequency of 20 Hz. The optimum value of step size is. So the optimum value of step size is nothing but del by ts is equals to dm of t by dt, which is delta is nothing but a step size, 1 by ts is nothing but sampling frequency, which is 20 Hz here. The slope of m of t is 0.1, hence del of t is equals to 0.1 divided by 20, which is 1 by 200, which is 1 by 2 into 10 power minus 2. So 5 into 10 power minus 3, that is 5 millivolts is the correct option. That is option B is correct. Of the following does represents the E field variations in for TE to 0 mode in the cross section of a hollow metallic waveguide. Here, first of all, in order to know the answer, we have to know what TE, M, N represents. Here, M and N are the the field variations M represents half-wave field variations along A side, whereas N represents number of half-wave variations along B side. So this is the broader dimension, this is the narrow dimension. Here see, in case of T to 0 mode, M is equals to 2 and N equals to 0. That means the two half-wave variations along the breadth, that is option C is correct, because this is the variation is occurring along the breadth. The circuit shown in figure, the current I is, okay, first of all, I2 is equals to 2 amps. V is equals to I4 into 3R plus I3 into 4R. So I2 is equals to 2 amps, I3 is equals to 1 amp, I4 is equals to 4 amps. So if we substitute V equals to 16R, so I is nothing but 16R divided by 8R, which is 2R. Hence option D is the correct answer. Consider a transmission line of characteristic impedance of 50 ohms if it is terminated by at one end by 50 ohms, Z50 ohms and capacitive reactance of Z50 ohms. Then VSWR in cases of A and B and C. That is, completely VSWR depends upon the magnitude of the reflection coefficient, that is 1 plus rho by 1 minus rho. Rho is nothing but magnitude of the reflection coefficient, that is ZL minus Z0 by ZL plus Z0. So in the case of first, it is a matched one. So the reflection coefficient is going to be 0. So VA, that is voltage standing wave ratio in case of case A, that is 1. So if it is terminated with J50, rho is equals to J50 minus 50 divided by J50 plus 50. So it is going to be J1 minus 1 by J1 plus 1, whose magnitudes are equal denominator. So rho is again 1. So the VB is equals to infinite. The reflection, the voltage standing wave ratio is infinite. Similarly, in the third case, that is whenever the transmission line is terminated by minus J50 ohms, rho is equals to minus J50 minus 50 divided by minus J50 plus J50. The magnitude is again equal. So rho is again 1 in the third case as well. So S is infinite. So the voltage standing wave ratio in both the cases, that is whenever the transmission line is terminated with the J50 as well as a capacitive reactance of J50, that is minus J50, in the both cases the voltage standing wave ratio is infinite. That means VSWR in both the cases are equal, whereas in case of A, that is equals to 1, so which is less than VB VC. That is option D is correct.